Everyone. My name is Anubhav, and today, for next 45 minutes, I will be talking about Cisco Multicloud Defense, and I will talk about how to secure your multi-cloud infrastructure at scale using Cisco Multicloud Defense. Before I talk about this particular product, let me set the stage right and talk a little bit about the application trend that we see today. When I talk to customers, these customers are installing application or provisioning applications everywhere. Applications are in the data center, applications are in the private cloud, co-location facilities, and in the public cloud as well. Now, with this particular trend, it is really difficult for a NetSec administrator or a security administrator to get the complete visibility and control. Reason for that is you have your applications spread across multiple infrastructures. Now, when we talk to these customers, biggest pain they call out is the single pane of glass, the single unified policy, and complete visibility and control. The other important item that I want to call out here is the scalability. All those applications are in the cloud using the agility, auto scale, resiliency, and they use multi-availability zone, multi-AZ applications, multi-region applications, and it is really important for our customers to have a solution that can provide complete visibility of their entire infrastructure. You can obviously go ahead and use cloud-provided security solutions, but sooner or later, when you are on your multi-cloud journey, you will end up in a situation where you will have a siloed security solution for each cloud provider. This is where multi-cloud defense can help you. And if I talk about this particular architecture at a very high level, we have the control plane, and then we have data plane. Control plane is provided to you as a SaaS offer. You can purchase it, and once you get access to the controller, we provide you access to the SaaS portal. And from the SaaS portal, you can control your gateways. And these gateways are in the data plane. So these gateways are not deployed inside of Cisco infrastructure. These gateways are deployed in customers' infrastructure. So if you have a compliance policy that your traffic should stay local, you can use these gateways inside of your infrastructure. When you deploy security in your infrastructure, these gateways are provided to you as a PaaS, so platform as a service. You don't have to really worry about the life cycle of the gateways, because these gateways are managed and controlled by controller. And controller is a highly scalable, resilient service available. We have customers with a large number of gateways managed by the controller. Now, when I talk about these gateways can be installed inside AWS, Azure, GCP, and OCI. Now, in terms of automation and orchestration, what we do is we touch various points like network visibility. So when you run this particular solution, and first thing that you will do is you will onboard your cloud infrastructure into your SaaS portal. The moment you enable that kind of integration between the controller and your cloud infrastructure, we learn about your infrastructure. We learn about your VPCs, we learn about your assets, we learn about your EC2 instances, and we learn about other components as well, like your transit gateway, your gateway load balancer, your network security groups, and we learn everything about your infrastructure. And we do that in a secured way by using IAM policy. Now, once we have that information, we display that information on a single dashboard so that you have complete information about your AWS, Azure, GCP, and OCI infrastructure, and you can take actions accordingly. The other automation that we provide is we insert these gateways into your accounts using the entire automated workflow. You just have to specify where you want to deploy these instances and or gateways, and then the controller will talk to your AWS or your cloud infrastructure and deploy and insert those gateways inside of your infrastructure. The biggest pain point for any administrator in the cloud when they insert security appliances is the traffic steering, because sometimes routing can be pretty complex in the cloud. So the multi-cloud defense controller will take care of that as well. And later this year, we are also adding multi-cloud networking piece to this particular architecture, which will help you connect different clouds together using a secured connection. And I will talk about that in the upcoming slide. In addition to that, whatever option you see in the UI can be fully automated and orchestrated using Terraform. We provide Terraform providers, we provide you Terraform templates, and for the logging, we have integration with Splunk, Datadog, and others. So all the logs that we get, you can always forward those logs to these providers as well. The biggest challenge in the cloud is all the applications are majorly deployed in auto-scale fashion, where application will scale up or scale down with load. And defining a policy based on IP address is not the correct way to define security in the cloud. So what we do is when we integrate our controller with your cloud infrastructure, we go out and enable a pub and sub model where we gain information about the tags, and you can define your policies based on tags, and we learn these tags in real time. You can use these tags in your policy, and you can use your tags across the cloud as well. For example, if you have your application 1 sitting in AWS, application 2 is in GCP, you can create a tag app AWS for applications in AWS and app GCP for applications in GCP, and then use these tags into a single policy and apply it to the gateways. So these policies will automatically be updated as soon as there is any change in your infrastructure, because we get the information in real time, and then we send that information across to the gateways in real time as well.
So with that, if a developer decides, hey, I want to throw a public IP on my ECS instance, will this detect it, then wrap policy around that?
Yeah, that's a good question. So when we define a policy, you can define it based on IP addresses as well. You can define it based on tags. There are other attributes as well that you can use while defining a policy. So the tag is one of the ways that is used for majorly for the internal communication, but you can use IP addresses as well.
But that would require you to know the IP. I'm just like, they decide, I don't want to deal with asking for a firewall policy to be opened to allow this traffic. I'm just going to throw an IP on here and make it open to the public internet. Will this detect that?
So you're saying that you want to write a policy without knowing the IP address. You can use FQDN in the policy as well.
Well, being able to detect a developer doing something without following policy of saying, hey, I want to allow traffic to here, just going and doing it themselves. Because you said it gets auto-updated from the backend.
So when we talk about the update, the tag-based policies, it take the information directly from the AWS provider. Whatever tag information is received from there. And in majority of the cases, when we deploy this solution, it is for Ingress, Egress, and EastWest. When your traffic is Ingress, definitely that traffic will hit your network load balancer, and then it will hit our gateway. So that flow is entirely different from the EastWest. For EastWest, we definitely use the unified tag-based policies. But for the Ingress traffic, whatever FQDN is available on the network load balancer, you will be using that. And for the Ingress use case, our recommendation is to go with the private subnet part and avoid assigning elastic IP addresses directly on the application, so that traffic will come to the network load balancer, hit the gateway, then we do all the security magic on the gateway, and then send it to the application.
Okay, so it's dependent upon
the flow.
People working in the infrastructure playing by the rules that have been set up. Not going.
Not exactly. Not exactly. But if you have a kind of a requirement where you want to assign elastic IP address directly on the instance, there are ways to do it. But that will not be using the unified tag-based policy. But there are other ways to do it. We can discuss that.
Okay.
Yeah, this is Steve. I have a question about the tagging import process that you mentioned in the previous slide here.
Yeah.
So when you're doing the learning of the tags that are out there across my multi-clouds, these are often run by different teams. So what's the process look like when you have the same tag being used in, say, Oracle and Azure, but they're really complete completely different in their different teams? How do you untangle that, and what kind of reporting do you have to help make that easy to see that those are completely different things, even though they're tagged the same?
Yeah, so what we assume is we have the security team working on the security policy, networking team working on the implementation and deployment of instances, and they do all the tagging of the workloads, right? So the assumption is when you create a policy, your security team should work closely with the networking team as well. In some cases, those teams are entirely the same teams, but definitely whatever tag we will learn directly from the instance, we will apply that into the policy. Along with that, you can add other attributes as well, like your IP addresses and other options as well. But whatever tag we learn from the security policy, we will use that in the policy. For example, if you have a three-tier architecture and you have web, app, and database tier, and your policy says that your web should have access to app, and that is something which we learn directly from your workloads and apply that in the policy.
Okay, so it sounds like this is primarily a manual process by the networking and security teams,
Yes.
and it's
So,
not really a discovery process.
Yes, right. So at the time of deployment of your instance, you define a tag there, and we will pull information from that tag and reuse that in the policy.
Okay.
The tag namespace is a one unified global namespace across all cloud instances, or is it prefixed with a tree? Then there's a hierarchy based on which cloud it's coming from.
I'll show you that in the demo today. So I have a demo where I will talk about the tag. So we gain tag from each cloud provider and then reuse that in the policy. I'll show you that in the demo.
Yeah, that's what was confusing me, because we do obviously tag everything that we do in the clouds and the providers. I'm assuming you're ingesting that as part of this, right?
Yes.
Yeah, and so therefore, the Oracle people hate the AWS people, so they don't talk to each other, and they're using the same labels.
Yeah. They could label the tag collision, right? How do you resolve that?
Because collisions. Thank you.
We don't have control over those tags. They make it up themselves.
Okay. Yeah.
Yeah, they're certainly not going to let me suggest any changes.
Yeah. Right.
Really? I'm confused. If we're talking about the thing that I think we're talking about, which is resource or instance tags, those kinds of things.
Yeah.
Then it's a matter of policy, isn't it? I mean, I've worked in many organizations that are multi-cloud where there are a mandatory set of tags for billing purposes, for example.
Right.
So I'm a little, I'm not catching the fact. I mean, obviously these groups, as Steve says, don't necessarily play nice.
Yeah.
But to be able to deploy in the cloud, you've got to have some kind of architectural standard, don't you? That says thou shalt use this tag, this key value pair for some purpose.
Yeah, this portion will be more clear when I'll show you the demo.
Cool.
I'm trying to envision how I handle those collisions as they come in, and what that interface looks like, and how you turn them into this policy you're talking about. So maybe it'll be clearer then.
Sure. So now coming back to the slide again, whatever you see in the UI can be fully orchestrated using the Terraform, and we actively provide you the Terraform templates, Terraform providers, and REST API. So we have our GitHub repos available where we keep on posting and adding all the information. So for those customers who are interested in using the automation and orchestration for deploying their infrastructure, they can definitely use it for deploying infrastructure, for deploying policy. So policy as code or infrastructure as code is fully supported with this particular architecture.
Could I ask a question about that very quickly? So I'm just scanning the Terraform in the screenshot here, and it looks like just initial setup, right?
Yeah.
So what happens when the device, the controller, begins to drift from the settings that you have initially specified in your Terraform deployment?
So you can do a version control here. So what you can do is you can deploy settings here, and then use the UI. If you're making changes to your infrastructure, you're just making changes to the policy. And our recommendation is, if you want to go with the Terraform way, fully infrastructure as code way, our recommendation is to use that particular option and push your policies directly from there. Or you can go with the UI configuration way as well. But if you drift, our recommendation is to use one or the other. not both at the same time for same specific infrastructure. For example, if you have your infrastructure in US East and you are using infrastructure as code for that particular infrastructure, recommendation is to go with that. Because it is really easy to drift your configuration by just making changes directly to.
Exactly.
Yeah, right.
That's the problem.
Right. Now, this is how the landing page of Cisco Defense Orchestrator or CDO looks like. So CDO is our cloud provided or management platform from where you can manage ASA, FTD, Umbrella, and there are different other options available. We have added multi-cloud defense as part of the CDO as well. You can launch CDO directly from there. This is the dashboard, how it looks like. I'm going to talk a little bit more about this dashboard in a bit when I'll start the demo. But on this particular dashboard, you can see that we have all the information about our cloud accounts, cloud resources. We have information about the top ports with malware traffic, security considerations. So this dashboard is going to give you complete information of what is happening in your infrastructure, no matter where your application is deployed in AWS, Azure, GCP, or OCI. You get complete information on the dashboard, and then you can take action. Now, coming back to the gateways. So I talked about gateways. Gateways are provided as a platform as a service. You don't have to worry about the lifecycle management of the gateways because gateways are directly handled by the controller itself. And these gateways are available in 2, 4, and 8 vCPU instances, and we have Egress gateway for protecting your Egress traffic. So any traffic coming towards your application, if your application is hosted in the cloud, it is inspected by Egress gateway. Then we have Egress gateway as well. Egress gateway is for those use cases when your application would like to talk to internet for downloading any patches or some sort of code. You can use Egress gateway. Egress gateway is also used for east-west traffic inspection, and based on the use cases and traffic flow, we have listed all the features and capabilities that we use or provide with the gateway. Now, our entire architecture is a single pass architecture. We do not do any sort of service chaining for achieving these capabilities and security. And in addition to that, when you write your rules, we ask you a question whether you want to use a rule-based in the forwarding mode or in policy or in proxy. So if you choose proxy, you can enable things like forward proxy, reverse proxy. You can also use forwarding mode as well if there is no requirement to enable proxy in your infrastructure. Now, when I talk about deployment models, there are different deployment models in the cloud. When you talk to cloud service providers, they talk about centralized security model and distributed security model. Centralized security model is a model where you have a security VPC, security VNet or VCN, and then you have your application VPCs, which are spoke VPCs. Now, when we deploy gateways, we take care of the complete deployment. When we deploy gateways in the centralized security model, we enable Ingress gateway. We can deploy Egress gateway, and at the same time, when these gateways are deployed, we enable autoscale is enabled by default, and autoscale is also kind of multi-AZ aware. So when we scale up or scale down, we make sure that our applications and our gateways are spread across multiple availability zones. The controller handles the lifecycle management, things like instantiation of gateways, scalability, reliability, upgrade, management, and hitless upgrade signatures is automatically done by the controller. Now, if I go to distributed security model, in some cases where you have a company taking care of multiple smaller customers, they would like to have a distributed security model as well, and we fully support that. You can put your gateways directly into the spoke VPC as well, and control everything using a single controller. Then we have combined security model as well. So in some cases, what we have seen is we have a hub and spoke model where we have security appliances in the hub providing all the security functions. Few VPCs are connected to centralized security VPC for inspection, and there are few VPCs where you have direct internet access. And for those kind of use cases, we put our gateways directly into the VPC, and the combined security model is also supported.
Can I ask a question?
Yeah.
Which of these models is more appropriate for AWS Transit Gateway, which are not really hub and spoke?
So for the transit gateway, we recommend the centralized security model, and I will show you that in the next slide.
Okay.
Let me
Sorry.
see.
Go
Let
ahead.
me see if I have that slide handy here. But I'll talk about that in a bit. But the centralized security model will have the transit gateway. It will have gateway load balancer endpoint, and our gateways in the security VPC. And transit gateway will connect to different application VPCs. I'll talk about that in a bit. Now, if I talk about egress traffic flow in the centralized security model is always sent to the security VPC for inspection and then to the internet, because the recommendation is not to have direct internet access in the application VPCs. And in the centralized security model, the internet connection is directly in the spoke VPC. That's why we have the gateways directly sitting inside of the VPC. And again, autoscale is enabled by default, and we have multi-AZ support for that. Ingress gateway is for inbound traffic coming towards your application. If it is a centralized security model, traffic will hit the network load balancer, which is part of the security VPC, and then it will go back to the destination VPC. Now, in case of the distributed security model, traffic will straight away come to the VPC because there is the direct internet access available in the application VPC. East-west segmentation is really important because this flow is like your VPC to VPC, VPC to data center, or data center to VPC flow. We can handle that with our egress gateway. So any traffic going towards your destination VPC will first come to centralized VPC for inspection and then go to the destination VPC. The other use case is the distributed, and specifically this use case is for distributed security model, where you have tiered architecture like web, database, and app in a VPC, and you want to route your traffic to the egress gateway for inspection. That can also be handled using the routing functionality that we provide with multi-cloud defense. And later this year, we are adding another type of gateway. It's not like another gateway, but we are adding VPN capability on egress gateway as well, which will enable cloud-to-cloud connectivity. For example, if you have your security VPC in AWS and you want to talk to GCP VPC in GCP, and you have your egress gateway in GCP, and you have your egress gateway inside of the security VPC, what we are going to do is we are going to provide you a checkbox. Using the checkbox, you can enable VPN capabilities on your egress gateway, and we will auto-instantiate IPsec tunnel between your security VPC and your GCP VPC as well. So this is the function that we are going to add later this year, and we are also adding functionality for site to cloud, where the VPN-enabled egress gateway is in the centralized VPC in your AWS infrastructure. It could be centralized VPC, it could be a centralized security VNet or VCN. But if you have this functionality enabled, VPN functionality enabled on your virtual appliance, you can form tunnel back to your data center. Only requirement for your data center edge device is that it should support IPsec route-based VPN, so that we can form auto tunnel with your infrastructure and learn all the routes and share routes using BGP. Now, this is the architecture that you see here, and I want to talk about this architecture. It is the reference architecture by AWS. You have your hub and spoke model here. I would say on the left side you have your security VPC, and then you have your application VPCs, and transit gateway is in the middle. Consider transit gateway as a device connecting all these VPCs together, and all your security functions are in the security VPC. Now, if you look at this particular architecture, you have a lot of knobs and switches, like you have your route tables, you have your transit gateway, you have route table for your transit gateway, you have your gateway load balancer, you have gateway load balancer endpoint. Cloud service provider will provide you Terraform. They will provide you CFTs to enable this kind of architecture. But in the end, you have to do a lot of manual work in order to achieve this architecture. But with multi-cloud defense, what we tell you do is onboard your infrastructure. Once your infrastructure is onboarded, tell us what type of security model you want to deploy, whether you want to go with centralized security model or distributed security model. If you say, I want to go with centralized security model, we give you option to create a centralized security VPC automatically. And in that VPC, based on the type of flow you are selecting, whether you're selecting ingress flow or egress flow, we will deploy gateways as well. And along with those gateways, we will deploy gateway load balancer endpoint. We will ensure that we attach this security VPC back to your transit gateway. It can be a new transit gateway. It can be an existing transit gateway as well. For example, if you already have a transit gateway where your application VPCs are connected, we can connect back to that transit gateway as well. And then the third step is to deploy gateways and switch traffic to those gateways for further inspection. So the entire automation or orchestration of this particular architecture is done automatically by the multi-cloud defense controller.
So does it physically manifest in your AWS account as a CloudFormation template?
Yes.
Or, okay.
Yes. 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 And this is the ingress traffic flow. If I look at this particular flow, traffic will first land on the internet gateway. From internet gateway, we send this traffic to the network load balancer. And from network load balancer, based on your flow, we'll send it to the gateway, ingress gateway, and then we send it to transit gateway and then to the destination application. So this is the inbound flow. And now if you look at the egress flow is the flow initiated from your application to the internet. So traffic will first go to your transit gateway will then send it to gateway load balancer. And between the gateway load balancer and our egress gateway, we have Geneve running. So if you have multiple egress gateways, Geneve will embed the identifier into the Geneve. We will embed the identifier in the Geneve protocol, and we'll make sure that traffic is symmetric. And this is how we enable egress gateway for centralized VPC as well. This is your east-west traffic implementation, where we use egress gateways and we send traffic to transit gateway. From transit gateway, we send it to gateway load balancer, then to the multi-cloud defense gateways, inspect traffic, and send it to the destination VPC via same route. So all the automation orchestration associated to this traffic flow is handled automatically by the multi-cloud defense controller. Now, looking at this particular architecture, this is the architecture for Azure. In Azure, we have security VNet in the middle, and then we have, security VNet on the left-hand side, and then we have application VNets. And these VNets are connected using VPC peering. Now, if you look at this architecture again, it is really difficult to have the complete architecture built using a single ARM template. You have to play with a lot of other components as well, like UDR. You have to play with adding policies on the devices. So whatever you see in this architecture, if you onboard your Azure subscription into multi-cloud defense, we will help you configure the security VPC. It's not only configuring the infrastructure, it's more than configuring the infrastructure, because we configure the infrastructure, we deploy security gateways, and we provide you policies based on the learnings that we do from your cloud infrastructure. So anything related to peering, routing, load balancer configuration, auto scale is done automatically by the multi-cloud defense controller. This is the egress traffic flow, where we use the egress load balancer. It is the internal load balancer. So we receive traffic from the application via VNet peering on the internal load balancer. Then we send it to egress gateway, and from egress gateway, we send it to the internet.
So just to clarify in my mind, in Azure, the gateway is the controller for a VPC that's connected, for a connected VPC that may be in another subscription.
So you have a controller on top. Controller can, in your controller, you can add multiple subscriptions. Let's say you have onboarded subscription 1. In that subscription, while deploying security, you will define you want to go with security, centralized deployment, or distributed. If you pick centralized deployment, we will create a security VNet. Now, this security VNet will connect back to your application VNets using VNet peering. Now, the gateway will sit in that security VPC, and it is managed by the controller. And if you plan to add more VNets, you can add another subscription in you can add another VPC in the same account, or you can add another subscription and add VPC there. So controller will act as a manager for all your accounts. Now, EastWest Traffic, for EastWest Traffic, we use similar kind of architecture. We send this traffic to internal load balancer. From internal load balancer, we send it to your gateways, and gateway will inspect the traffic, send it back to the destination VPC. Now, we have similar architecture available for GCP as well. If you have your GCP accounts, you can onboard your GCP account, create a centralized security model, whereas in the centralized security model, we create security VPC, connect it using VPC peering, and we send traffic to the internal load balancer and external load balancer based on your traffic flow. Since this is the slide for Egress traffic flow, your traffic is first received on the public load balancer. From there, we send it to gateways, and from gateways, we send it to the destination VPC. The other flow is the egress traffic flow. We send traffic to the load balancer through the VPC peering, and then we send it to gateways for inspection. And if everything is allowed, we send it to the internet. EastWest is again, we use Egress traffic, Egress Multicloud Defense gateways. So we send traffic to our internal load balancer, inspect it on the gateways, and we send it back to the destination VPC. Now, this is a little bit about Oracle Cloud OCI. If you look at this architecture here, you have centralized VCN in the middle, and you have application VPC on the left and application VPC on the right, but the right side application VPCs are in the different region. So the way we connect is we use local peering gateways for local VPC peering, and we use dynamic routing gateways for across region peering, and then we put our security appliances directly in the security VCN. And in this architecture, the things that we orchestrate is the insertion of devices. We enable auto scaling, and we ensure that your load balancers are fully configured and added in the architecture. This is the egress traffic flow, similar kind of architecture, but the flow is a little bit different because traffic is initiated from outside. It lands on the public load balancers first, and then on the gateways, and from gateways, we send it to the destination. And this is EastWest, so egress gateways are used, and using the egress gateways, we send traffic from one VCN to another VCN. So the entire solution is fully orchestrated. And this is the high-level overview of the controller. Controller manages all your cloud accounts, and you can onboard your cloud accounts and then define whether you want to go with security, centralized security VPC, or a distributed VPC model. And then we enable security policies and insert gateways seamlessly into the architecture, and we enable security flow accordingly. Now, this is a quick demo. So this is the Cisco Defense Orchestrator page, and on the Cisco Defense Orchestrator page, you can add your ASA, you can add your FTD, you can have other things like your account, your AWS account, and manage everything directly from the Cisco Defense Orchestrator. Now, in Cisco Defense Orchestrator, we have added multi-cloud defense as well. The moment you click on that, we give you access to this dashboard. In this dashboard, we have information about all your cloud accounts. So the first thing that you will do is you will onboard your infrastructure. This dashboard shows you the account information, asset information, information about VPC, traffic, DNS, security consideration. It is going to give you information about security groups, network security groups, number of load balancers, number of transit gateways you have. It will display information about threat by country. It's going to give you some information about exfiltration events as well. And this is fully customizable. You can customize it according to your need. And if I click on setup, this is the place where you begin your journey with multi-cloud defense. In the multi-cloud defense, first thing that you will do is you will onboard your infrastructure. When you click on connect account, we ask you to run a CloudFormation template. That CloudFormation template will enable some IAM permissions, and we can share the document what kind of permission we need. Once your cloud account is onboarded, you can enable traffic visibility. For traffic visibility, you can enable VPC flow logs, NSG flow logs, DNS query logs, and that way we learn more about the infrastructure. And the third piece is the secure account, where you define whether you want to have a shared security model, centralized security model, or a distributed security model. But if you go to the discovery page, it is going to give you detailed information, because we are learning this information directly from your account, and we are learning about your tags as well from your cloud accounts. So this is going to give you detailed information on what are the key destination, DNS destination your instance is trying to access. And if you click on VPC, it is going to give you information about your VPC instances, about your VNet instances, or EC2 instances, or VMs running inside of your cloud infrastructure. You can double click on any of these items to get more information about what is happening, what is the top contributor for traffic, and where exactly these instances are going. And based on that, you can drill down, you can click on the information and take further action. Now, if I click on topology, this is the place where you get complete information about your infrastructure. So here, you can see I have my AWS infrastructure, Azure infrastructure, GCP infrastructure, and you will see entire cloud infrastructure here. If you are on a journey of multi-cloud, you can onboard your entire cloud infrastructure here. And this is the VPC where I have EC2 instance with malicious activity. So if I click on that, if I drill down, and if I click on that particular information, it is going to give me more information about that EC2 instance. And if I double click on that, it will give me what subnet this workload is in, and what is the EC2 instance ID, and what kind of destination this EC2 instance is trying to access. Now, if I go to this particular instance, I can get more information about the destination, and I also get information about tags. I get information about, and there is a policy recommendation directly from the multi-cloud defense that this instance is trying to reach some malicious destination, and we get all our intelligence from Cisco Talos, and we use third-party intelligence providers as well. But what you can do is you can create a policy here and block your traffic. The other deployment that I want to show you today is the centralized VPC deployment. In this centralized VPC deployment, we have a security VPC with ingress and egress gateways. It was fully orchestrated and deployed using the controller. So I onboarded my AWS account, and then using the automation and orchestration provided by Multi-Cloud Defense, I orchestrated egress and ingress gateway in this particular VPC. Now, if I go back to my gateway page, you can see I have ingress gateway, and there is gateway endpoint, and this gateway endpoint is the FQDN of the network load balancer. So I was able to access my internal application using that FQDN. And the other option I want to show you is the EastWest traffic flow and Egress traffic flow. So I have application 1 sitting in VPC 1, application 2 is in VPC 2. I can initiate traffic directly from my VPC, and there is no direct internet connectivity in my VPC. So traffic will always come to my centralized security VPC, and from centralized security VPC, I go to internet. Now, right now, since I have a policy saying that app 1 is allowed to internet, app 2 is allowed to internet, app 1 is allowed to access app 2, and app 2 is allowed to access app 1. That's the reason all traffic flows are working permanently fine. But if I go back to my AWS console, and if I change my tag to something else, this communication will break. So that's what I want to show you next. And using this particular flow, what I can do is I can enable dynamic policies. Now, if I go and change my policies or my tag to XYZ from app 2, instantly we will learn this information in real time, and we update our policy, and you can see that our right now traffic is allowed. But if I go and refresh, if I initiate that traffic because I have changed my tag, the moment I refresh my policy, you can see that traffic is now blocked. And that was a short demo on the multi-cloud defense. But coming back to the bigger picture, you can onboard your entire cloud infrastructure into multi-cloud defense, enable security, insert security seamlessly, and you can enable centralized security model or a distributed security model.